Okay, so for question 9 it says prove from first principles that the derivative of x to the 4 is 4x cubed. So this is a first principles question. Now whenever this is the case, you'll be going back to the formula sheet because there's a specific formula for differentiation from first principles. It's one of the proof questions. You cannot just state that this is your y or your f of x and then differentiate it to find that you've got to show the full method. Now, to start this, we're going to say that our f of x is equal to x to the 4. Now, the differentiation from first principles, f dashed of x, tells the limit as h goes to 0 of f of x plus h minus f of x all over h. That's what the differential is. Okay, that's the formula given on the formula sheet. And remember, that really comes through the idea of a gradient of a chord on a curve and then getting that distance infinitesimally smaller. Which is why our HR difference there is going to 0. So we've got our general expression, we can substitute it into this, so we've still got our limit as h goes to 0. Our f of x is being replaced with f of x plus h, so instead of an x here, we replace that with x plus h, still to the power of 4, minus our f of x, which is x to the 4, all divided by h. Now, to deal with this, we need to do this expansion of x plus h to the 4. Now, you could sit there and expand 4 brackets, but the simpler idea is to use the binomial expansion, or because you've got the singular x there, actually this one's quite a nice one that you can actually use Pascal's triangle to find out what the coefficients are, and actually it's quite quick for this, because if the power is 4, we need to go up to the 5th row. So actually it's probably faster than using the expansion. So from that then, we can expand this x plus h to the 4. We have a coefficient of 1 with x to the power of 4 plus a coefficient of 4, x now to the power of 3, h to the power of 1, plus the next coefficient 6, x to the power of 2, h squared, remember the powers are adding up to 4 each time, plus the next coefficient 4, x h cubed, plus the coefficient of 1, h to the 4. So that's our x plus h to the 4 expanded, minus x to the 4 all over h. So if we simplify this then, the x to the 4's here are going to cancel. We've still got the limit as h goes to 0. And if I divide all the other terms by h, we've got 4x cubed plus 6x squared h plus 4xh squared plus h cubed. Now, we can state as h goes to 0, this implies 6x squared, h must go to 0, as 0 is the multiplier there, and 4xh squared must go to 0, as 0 squared is still 0, and h cubed must go to 0 as well. So all that's going to leave us with then is 4x cubed. So therefore, let's just tie that up with a sentence. The derivative of x to the 4 is 4x cubed. And that is realistically what they're looking for. You can use the binomial expansion, you could even expand the 4 brackets, but for this particular one, Pascal's is probably the fastest way to get there. Moving on to question 10 then. You're given the equation of a circle, nice standard form, and a very standard question. They want the coordinates of the centre and the exact radius of the circle. So you're going to have to complete the square twice on this, once on the x's, once on the y's. Now my suggestion before you do is just to group the x terms together, group the y terms together like that. It just makes it a little bit clearer when you complete the square. So if we complete the square on the first one, we have x minus 4x we have, so it's minus 2 squared minus this 2 squared, 4, because remember, really if we expand this, we're trying to make it back to this x squared minus 4x, so because this would generate a plus 4, we need to do the minus 4 to get rid of it. Plus, same idea with the y's, y plus half the 8 is 4 squared minus, because that would produce a plus 16, so we subtract 16 minus this 8 here is equal to 0. So we have x minus 2 squared plus y plus 4 squared. Minus 4 minus 16 is minus 20, minus 8 minus 28, moves to the other side, becomes a plus 28. This is the useful form for us, because we can now take out our centre. Now remember, when you take the coordinates of the centre, it's the values that will make these brackets both go to 0. So the first one is going to be a plus 2 there, and the second one a minus 4 there for the y. For the radius then, in this format, that 28 is equal to r squared, so the radius is equal to root 28, or in other words 2 root 7 in its simplified form. So those are our centre and radius values, and remember it says exact radius, so you do need to get the surd form. Part B says the straight line x is equal to k, where k is a constant, is a tangent to C. Find the possible values for k. Now, there's two ways you can do this. One is you can use the idea it's a tangent and go on to solve an equation with that, but that's actually more difficult to do, and you don't need to for this point, because the straight line that's given is x is equal to k. Now, if it's x is equal to a constant, it means that you've got a vertical line. Now, this is the equation of a circle. So if we draw ourselves a circle, and we have our centre, 2 minus 4 there, if x equals k is a vertical line, and it's a tangent, which means it only touches at one point, there's only two places we can have a vertical line. That is here, and here, and they must correspond to our two values of k, these two lines here. Now, because they're touching at one point, it must be the furthest point to the left and the furthest point to the right from the centre. But we already know something from our centre, that the distance between this to the circumference of the circle must be a radius away, so it must be a 2 root 7. That way, and likewise a 2 root 7. Well, because it's in relation to the x coordinate, if we're looking at our coordinate for, let's call that point A there, it must be 2 minus 2 root 7. The y coordinate would be the same, that would just be minus 4. And this point, let's call that point B there, must be 2 plus 2 root 7, and again the y coordinate would be the same. Okay, so in other words, we can say that our values of k must either be that x or k is equal to 2 minus 2 root 7, or the k on this side is equal to 2 plus 2 root 7. And those are our two possible values.